How does the Falcon 9 work? According to SpaceX stats, rockets from the Falcon 9 family had launched 127 satellites and took part in 135 full missions, with only 2 failures. This counts for a 98.43% success rate. And the newest 2018 Falcon Heavy only flew 3 missions so far, but there are more plans for the future. Falcon 9 is the world's first orbital-class reusable rocket. Reusability allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. Dimensions. To describe the engineering behind the Falcon 9 rocket, it is worth mentioning its measurements. The rocket is almost 70 meters tall, has about 549 kilograms weight, and can generate over 7,500 kN of thrust at takeoff. This means Falcon 9 can send 22,800 kilograms into orbit around the Earth, as well as 8,300 kilograms to Mars. But they haven't done anything on the red planet yet. Mars is Elon Musk and SpaceX plan to go to, as they want to eventually land people there. 2-stage rocket engines. The previous versions of Falcon had 2 stages and used 9 engines arranged in 3 rows of 3 in its first stage. The newer one is placed in an orientation with 1 in the inside center and the other 8 engines circling it. Metal octaweb structure houses the Merlin engines, and it is crucial for the first stage. The second stage works only with 1 engine that uses liquid oxygen. It also needs rocket-grade kerosene for the propellants during the gas generator's power cycle. Both of the engines together generate 1.7 million pounds of thrust. The Merlin engine is built in-house by SpaceX and contains a combination of rocket-grade kerosene called Rocket Propellant 1 and liquid oxygen. It is incredibly powerful and one of the most efficient engines ever built. Stage separation. Any multi-stage rocket needs an interstage, which is sometimes difficult to create, but the Falcon 9 made it simpler. To separate stages, most rockets utilize a sophisticated pyrotechnic system of exploding bolts, whereas SpaceX uses an all-pneumatic stage separation method. The interstage links the first and second stages. The second stage's engine is housed in the interstage. This secures it during the initial phases of flight. The stage separation takes place when 2 stages disconnect at the correct moment of staging, allowing the second to explode securely. Falcon 9's historical moment happened when the Crew Dragon spacecraft went into orbit, an autonomous capsule with touch-sensitive controls for passengers to use during emergencies. The Crew Dragon can accommodate up to 7 people, but usually travels with 4. Payload. The Falcon 9 payload is made of a carbon composite material where the firing jettison approximately 3 minutes into the flight. This protects satellites on their way to orbit. SpaceX continues to recover fairing for reuse in future sessions. Landing. Landing it is the most exciting moment for the rocket. The first stage landing of Falcon 9 has 4 landing legs made of carbon fiber. They are flat folded against the fuselage until use. Onboard cold gas thrusters flip the rocket to position it with its engines facing forward. The process of landing happens when the rocket goes through staging. The first stage starts to fall through the atmosphere at a speed of 700 km per hour. The cold thrusters near the top flip the rocket around, so it is upright. The engine fires, enough to slow the fall to 20 km per hour. Then, the legs deploy and the final step happens. 3 of the 9 Merlin engines fire one more time, which is called the boost back burn. The cold thrusters near the top flip the rocket around, so it is upright. The engine fires, enough to slow the fall to 20 km per hour. Then, the legs deploy and the final step happens. 3 of the 9 Merlin engines fire one more time, which is called the boost back burn. Hardware and software. The first stage of the rocket landing is fully automated. Plenty of components respond in real time when different conditions occur. Also, the vehicle launch has an autonomous flight termination system. Thanks to computers, it is possible to detect some of the risks. Falcon 9 has 3 processors of dual-core x86. It uses an actor-judge system that bolsters safety through redundancy. Every decision is analyzed with the other 2 cores. As a result, the system can restart if there are any disagreements. If there is a match, the final process involves sending it to PowerPC microcontrollers that control the rocket's engines and grid behavior. Thank you very much for watching our video. If you like it, give it like, and if you want more interesting videos like this, don't hesitate to subscribe our channel and hit the bell icon.